ओके, लास्ट क्लास में वी स्टडीड अबाउट म्यूचुअल इंडक्टेंस का. म्यूचुअल इंडक्टेंस का फॉर्मूला याद है ना आपको? व्हेन एवर दे विल टेल टू फाइंड द म्यूचुअल इंडक्टेंस, आपको फ्लक्स फाइंड करने का, राइट? फ्लक्स इन second coil is equal to m times of I1, right? And EMF will be, tell me, EMF across the inductor, like mutual inductance की वजह से EMF कितना होगा?
m di/dt.
m mod d I1 by dt, right? So for mutual inductance के लिए आपको two coils are compulsory. We have to find flux, and flux you know from Faraday's laws. Faraday's law say B dot A we are trying to find. Okay, so one more small derivation is there. Mutual inductance of two long coaxial solids का mutual inductance value we are trying to find. Okay, so we have one coil inside coil, one coil outside coil. Okay, here inside में there is a winding, and outside में you have one more winding. Two coils are necessary to find mutual inductance. That's why we are taking two coils, long coaxial solenoid. And we have to keep the things, number of turns. Number of turns in the, see, I'm talking about outer coil and inner coil. Okay. Outer coil ka radius we are taking as capital, and inner coil ka radius we are taking smaller, and dono length is L and L. And this is the first coil, second coil, right? Okay. In outer coil ka number of turns per unit length is L1, and number of turns per unit length is N2, and number of turns is N1 outer coil ka, and number of turns in the secondary coil is N2. Okay. Our interest is to calculate mutual inductance of two coaxial solenoids. So uske liye I told you I will pass a current in the first coil mein. And you know magnetic field inside the solenoid, yaad hai na? Magnetic field inside the solenoid is mu naught Ni, mu naught Ni. So N is what? First turns ka N1 I1, right? Mu naught N1 I1. This is a magnetic field inside the solenoid when I pass a current I1 current. Okay. Now flux find करने वाले. Flux कितना होगा? Flux का flux in secondary coil. Tell me, whenever you flow a coil in the secondary coil, definitely primary coil में current pass किया तो the flux will be there. And flux का formula we are taking magnetic field and area vector is same initially. So BA, right? BA. But we have how many turns in the secondary में? N2 turns, right? So that's why N2 BA, right? And what is the area? N2, and magnetic field जगह में mu naught N1 I1, and area of the secondary coil radius is smaller, right? Pi R square. We are trying to find flux, from that only we'll get mutual inductance ka. So I want to convert into N1, N2, small N2, and what is N2 is number of turns per unit length, right? So N2 is equal to N2 into L. N2 into L mu naught N1 I1 pi R square. So therefore flux is equal to mu naught N1 N2 pi R square L times of I1. I1 को corner में फेंक दूंगा. And we know the formula. Flux 2 is equal to M times of I1. So from this, M is equal to mu naught N1 N2 pi R square L is the formula for mutual inductance of two coaxial solenoids. We learned inductance of a solenoid also. That is formula क्या था? Mu naught N square pi R square L. But here since there are two coils, N square नहीं रहेगा, N1 N2 रहेगा. That's it. In inductance में N square रहे, इसमें तो N1 N2 आएगा. I already substituted in the formula sheet में. Okay. चलो. Now we learn with the new concept, which is AC generator के बारे में learn करेंगे. Short form में we learn. हो गया? Complete. Now we'll go for a AC generator. Generator का काम क्या है? What is the purpose of generator? It converts which energy to which energy? Generally power गया तो they'll rotate with the turbines and then we'll get the current, right? So which energy? Mechanical energy to electrical energy. That is the function. मतलब we have to rotate either through automobile का कुछ diesel engines लगा के rotate करेगा, will convert into electrical energy. And here also we are using Faraday's laws only. Faraday's laws का principle only. Diagram दिखाऊंगा simply. उसका नाम मतलब याद रखो, that's it. Generator में you have two poles, right? Two magnets. And there is a armature बोलते हैं उसको. एक coil को armature बोलते हैं. And it has two rings, that is slip rings बोलते हैं. Slip rings. Okay. And there is a brushes. From here we will get output. We can connect with bulb or fan or input to the house we can give. So that total all equipments will work. Okay, AC generator से. Okay. So function क्या है, working क्या है देखो. So initially you put a coil like this. See, this is a coil. This is north pole. This is south pole. Okay, north pole south pole से the field lines are passing like this. Okay. So when I start rotating with the coil को मैं rotate करूँगा. So क्या होगा? Flux lines are changing or not? Tell me. Flux lines are changing because initially मान लो 10 lines are there. When I rotate like this, it is passing only one flux lines. And when again coming, again 10 lines are passing. So flux lines is changing, right? So Faraday ने क्या बोला? Whenever there is a change in flux, the EMF will be induced. And if it is a closed circuit, the current also will be induced. Okay, that is the principle. We are getting that current only by changing the flux lines only. Okay, so इसका क्या है derivation learn करेंगे. Suppose मान लो you have north pole and south pole. So magnetic field lines are like this. Okay, initially I put a coil like this. So magnetic field, north to south magnetic field and area vector are in the same direction. Angle is 0. BA. Okay. मैं क्या करूंगा, थोड़ा एंगल थीटा में रोटेट करूंगा, एक कॉइल को एंगल थीटा रोटेट करूंगा ऐसे. ओके, सम एंगल ऐसा रोटेट किया. रोटेट करने से क्या होगा, एरिया वेक्टर विल चेंज एंड मैग्नेटिक फील्ड तो ऐसा है, एंगल बिटवीन देम इज थीटा. ओके, फर्स्ट आई पुट द कॉइल लाइक दिस. इनिशियली बोथ आर सेम डायरेक्शन, एंगल इज 0. मैं क्या किया, इसको थोड़ा रोटेट किया. मतलब हम रोटेट करने से ओनली ईएमएफ विल बी इंड्यूस्ड, राइट? आई रोटेटेड सर, मैं एंगल थीटा रोटेट किया. रोटेट करने से एरिया वेक्टर इज चेंजिंग बट मैग्नेटिक फील्ड तो सेम ओनली. मैग्नेटिक फील्ड तो सेम, एंगल इज थीटा. नाउ फ्लक्स कितना होगा? फ्लक्स इज बी ए cos theta. If that coil has n turns, n ba cos theta. Okay, okay, but I want answer in terms of omega में. ओमेगा में चाहिए. आई एम रोटेटिंग विथ, इधर ऐसे रोटेट करूंगा. ओके, विथ ओमेगा से रोटेट करूंगा. ओमेगा इज व्हाट, याद है ना, एंगुलर वेलोसिटी इज एंगुलर डिस्प्लेसमेंट बाय टाइम. So theta is equal to omega t. Theta is equal to omega t. So I am substituting here. Flux is equal to NBA cos omega t. Now flux आ गया. Faraday's law क्या बोल रहा है? EMF induced is equal to mod d phi by dt. So d by dt of NBA cos omega t. Okay. So NBA constant बाहर आ जाएगा. And differentiation of पूरा mod में ना, differentiation of cos is minus sin omega t into omega t का differentiation is omega mod n. So minus निकाल दो. Therefore EMF will be NBA omega sin omega t. Right? Okay. What is the maximum EMF induced? E maximum कब होगा? When sin value is 1. इसको 1 से रिप्लेस करो. So what is the maximum value? NBA omega. And इसको maximum value को I call as E naught. Therefore EMF induced in the, when a coil rotates कितना होगा? E naught sin omega t. This is a formula for EMF induced. This is called instantaneous EMF. Instantaneous EMF. Now, matlab why instantaneous means every omega t angle में I can measure the EMF induced in the coil. Okay, and this is maximum EMF. These two formulas fit now. NBA omega. So if I know the EMF, I can find current also. Current is equal to E naught by R sin omega t. And E naught by R ko I call as I naught. I is equal to I naught sin omega t. This is the instantaneous current. Instantaneous current. And P, this is peak current. I naught is maximum value of current, right? So kitna hoga? E naught by R is the formula. And E naught already you know. NBA omega by R. E naught value. So this is the introduction for AC only. AC में starting only घर का voltage is coming this only sine waveform में आएगा घर का voltage. E naught sin omega t is the value which is coming our house voltage and current is I naught sin omega t. Sine wave मालूम है ना इधर upside downside ऐसा रहेगा sine wave का. Okay, copy it. So I'm done. Yes. देखो. So EMF का normally I told you sine का देखो ऐसा रहेगा. This is a sine waveform which is coming in our house में. Okay. Omega t change करता जाऊंगा 90 लगाए तो 1 आएगा 180 से 0 आएगा sin 270 is -1 sin 360 is 0. If I draw plot you will get the graph. मतलब पोजीशन चेंज होने से क्या होगा ऐसा चेंज होने से द EMF will be induced in the coil. Okay. चलो न्यूमेरिकल्स करेंगे. So what is the formula we learned? E is equal to E naught sin omega t is a formula. This is the instantaneous voltage. If I ask maximum voltage formula क्या है? NBA omega. This is the maximum voltage. And current का formula will be I naught sin omega t. And I naught is the E naught by R. R is the resistance. Okay. This formula based we have to solve the questions. NBA omega is the maximum voltage. This I naught is the maximum current. Chalo. AC generator consists of coil of 100 turns. Okay, N is given 100 turns. Area of the coil is 3 meters square. Rotating with angular speed, omega is given 60 radians per second. Uniform magnetic field is given 0.04 Tesla. And resistance of the coil also given 500 ohms. He's telling for maximum current drawn from the generator. Maximum current means I naught is how much?
Uh, 1.44.
1.44, yes, amperes. 1.44 amperes is the answer. Aya? I naught is E naught by R NBA omega by R. All values are given. Substitute. You will get as 1.44 amperes. This is the answer. Okay. So next. Armature means coil consists of this many turns. Area is given. Total resistance is given. It rotates under the magnetic field and frequency is given. Frequency is equal to 150 by pi hertz. Frequency say omega you can find, right? We know the relation. Omega is equal to 2 pi f. Now calculate the maximum EMF produced in the coil. And this average induced EMF produced in the coil is nothing but for one cycle, complete cycle. One complete cycle में average induced EMF is how much? It is 0. Because कितना positive होगा उतना negative होगा. So average EMF will be always 0 for complete cycle का. So second answer is 0. And first one, maximum EMF, NBA omega.
170.
No, wrong.
270.
270. Yeah, 270. 2 pi f is 150 by pi. So pi cancel 300. So E naught is NBA omega. So substitute values. कितना है श्याम?
Sir, 220.
220 wrong.
270, sorry, sir.
अरे your wish, हाँ? So 270 volts is answer. Okay. चलो साथी गया ना? Next. Kamla pedals a stationary bicycle, the pedals of which are attached to the 100 tons coil. Area is given. The coil rotates half a revolutions in 1 second. मतलब frequency is given as half revolutions per second. And it is placed in uniform manifold is given perpendicular to the axis of rotation. What is the maximum voltage generated in the coil? खत्म. In terms of pi में चाहिए.
Pi by 10.
Yes, correct. Aya, Sadik. Same formula. E max is equal to NBA omega. Omega is 2 pi f. Substitute all the values in the answer. Same आ गया. N is 100. Magnetic field, how much is given? 0.01. That is 1 by 100 only. Into area of the coil is 0.10. So what is 0.1, right? So 1 by 10. Into omega is 2 pi f. 2 pi into 1 by 2. So 2 to cancel. 100 cancel. It is pi by 10 volts. This is the EMF induced across the end. Okay. Chalo. The AC generator done. Okay. So one more small topic is there, which is growth and decay of current in LR circuits. LR circuits ka thoda sometimes they are asking the questions in this one. Easy only, formula based hai this one, growth and decay of so I told you inductance opposes what? Resistance opposes what? Resistance opposes the current. Inductance opposes the change in current. That is very important. Change in current. Okay. So suddenly change nahi karega. Suddenly, if you off the switch also, suddenly it will not become zero. Dhire dhire zero ho jayega. Okay. So that how it is current is increasing or decreasing, that we are seeing. So first we'll study about growth. and then we'll study about the decay, growth and decay of LR circuit. So growth of current in LR circuit mein, there is an inductor, there is a resistor. Inductance L, resistance R. I connected with a battery and one key. Okay. When you on the switch, what will happen? That will not allow suddenly increase in the current, right? Initially, will not allow sudden increase in current. So धीरे current बढ़ेगा because inductor opposes the change in current. Okay. So it will not, whether it will reach maximum value freedom, whether it reaches the maximum value suddenly in the circuit mein, no, because of inductor only. If there is no inductor, directly suddenly maximum ho jayega. But because of inductor, it will always opposes the change in current. धीरे maximum value बढ़ेगा. Okay. Now क्या होगा? आपको 3 conditions में पढ़ेंगे. One is at t equal to 0. T equal to 0 means at the instant when you on the switch. At that time, current is how much? Current is how much? When you on the switch at this instant mein, the current is 0 because inductor does not allow the current to sudden rise. Okay, so current is 0. This is called instant time. Instant time. Okay. Now, मान लो at t equal to infinity, बहुत टाइम हो गया. T tends to infinity, बहुत टाइम हो गया. Then क्या होगा? Current कितना होगा? Current will be maximum current will flow, right? That is the maximum current. Okay. That times, मतलब क्या होगा? That time inductor will act like a what? Inductor will act like simply short circuit. So inductor will act like a short circuit. Because once it reaches, suppose example 10 ampere तक maximum जाएगा बैटरी में. 10 amperes reach होने के बाद temp is constant. So it is not opposing anything. It is not opposing. So inductor रहेगा physically, but it कुछ काम नहीं करेगा. So it act like a short circuit. And this is acting like at this state, this is acting like a circuit is acting like a open circuit. Open circuit. What? Inductor. Inductor acting like a acts like open circuit, and inductor acts like short circuit. Okay. So मतलब बहुत टाइम में होने के बाद it is not changing any current. So inductor physically रहेगा but कुछ काम नहीं करेगा. It will allow total current. That time maximum current is how much? That time maximum current in the circuit is voltage upon resistance only, E by R, because only one resistance, one voltage is the maximum current flowing at the time of infinity. Okay. Now हम लोग बीच का कहानी देखेंगे. बीच का कहानी like in t equal 0 to t equal infinity के बीच में. ठीक है बेटा? Okay. Now at time t equal to between में time I'm taking now. So at time t is greater than 0, less than infinity. In third case में t is greater than 0, less than infinity. In that case में how it will act, inductor will see how the current is coming. So derivation we are not doing. So actually current, what will happen? It will increase or decrease when you on the switch. Current will increase, right? Exponential wise it will increase. Exponential wise it will increase. धीरे increase करेगा. And उसका current after solving, the current will be I is equal to I naught into 1 minus e power minus t by tau. This is the expression you will get. This is the current. I is equal to I naught into 1 minus e power minus t by tau is a current which is flowing in between these two conditions. Okay. So I equal to I naught into 1 minus e power minus t by tau is the formula where tau is equal to, tau is called inductive time constant. Inductive time constant, and tau is equal to L by R is the formula. Inductive time constant that is L by R. So देखो exponentially it is increasing. So what is the formula by heart करो? I is equal to I naught into 1 minus T by tau. देखो we'll talk about time constant and inductive time constant का. So what is the current? Tell me in between. I is equal to I naught into 1 minus e power minus T by tau is a formula. That much current. From this current we can find any time. At t equal 0 also you can find. At t equal infinity also you can find. Everything you can find from this general expression. At particular instant of time में current कितना है means we can find by this. Okay. मान लो at time t equal tau. Now calculate current कितना होगा? At small t is equal tau. Current find करो कितना आएगा? I is equal to I naught into 1 minus e power minus tau by tau is minus 1. Okay. So I is equal to I naught into 1 minus 1 by e. E is exponential value. And 1 by e ka value approximation you have to remember approximate as 0.37. 1 by e value is 0.37. Substitute here I is equal to I naught into 1 minus 1 by e is 0.638. That means indirectly लिखो there tau का definition लिखो. Tau is that time लिखो. Tau is that time in which current reaches 63% of its maximum value. 63% of its maximum value. मतलब एट द टाउ टाइम में आपको करंट कितना मैक्सिमम रीच हुआ? 63% मैक्सिमम रीच हुआ. द टाइम इज कॉल्ड टाउ. ओके, टाउ इज कॉल्ड टाइम कांस्टेंट. दैट इज टाउ इज इक्वल टू एल बाई आर बोलते हैं, इंडक्टिव टाइम कांस्टेंट, एल बाई आर. उसका ग्राफ ड्रॉ करेंगे. नो इसका ग्राफ भी ड्रॉ करेंगे. I versus time. इंडक्टिव रेजिस्टेंस सर्क्यूट में व्हेन यू ऑन द स्विच करंट ऐसा धीरे 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 एक्सपोनेंशियली वाइज इंक्रीज करेगा ऐसा एंड बिकम्स कांस्टेंट. ओके, एंड दिस वैल्यू इज नथिंग बट आई नॉट. पीक वैल्यू इज द मैक्सिमम वैल्यू कैन रीच आई नॉट. एंड टाउ टाइम में एट टाइम टी इक्वल टाउ में इट इज 0.63 टाइम्स ऑफ आई नॉट. 63% रीच हुआ करंट इन सर्क्यूट में. ओके, सो आपको टू स्टेट समझ में है ना. सो वेन एवर इंडक्टर एंड रेसिस्टर्स आर गिवन, आपको दे विल मेंशन एट टी इक्वल 0 में हाउ मच, एट टी इक्वल इन्फिनिटी में हाउ मच बोल के. एट टी इक्वल 0 में टेल मी इंडक्टर, उधर लिख लो शायद, फिर से लिखो, नोटबुक लिखो. एट टी इक्वल 0 नो सब्स करो. ए टू स्टेट्स में कंक्लूजन ले लो. देखो आई इज इक्वल टू आई नॉट इंटू 1 minus e power minus t by tau. This is the formula current का. At t equal 0 substitute करो and tell the answer. Current is how much? Anything power 0 is 1. E power 0 is 1. तो कितना होगा?
0.
हाँ 0. That means नीचे लिखो, no current flows in branch. No current flows in branch containing inductor. Containing inductor. ब्रैकेट में ओपन सर्क्यूट. दैट ओनली वी रोट बिफोर. ओपन सर्क्यूट. उस ब्रांच में इंडक्टर को सिंपली निकाल दो. ओपन सर्क्यूट. उस ब्रांच में करंट विल नॉट फ्लो व्हेनेवर सर्क्यूट इज गिवन. ओके, एंड टी इक्वल इन्फिनिटी सब्स करो इन द गिवन एक्सप्रेशन में एंड फाइंड करंट. इन्फिनिटी इज 1 by 0. कितना होगा? टी के जगह में इन्फिनिटी लगो. सो समथिंग इन्फिनिटी बाय समथिंग इज इन्फिनिटी ओनली. ई पावर माइनस इन्फिनिटी इज नथिंग बट 1 by e पावर इन्फिनिटी एंड एनीथिंग पावर इन्फिनिटी इज कितना? 0. सो ये पूरा टर्म 0 हो जाएगा. सो कितना बचेगा? आई इक्वल आई नॉट. राइट, व्हेन t इक्वल टू इन्फिनिटी सब्सिट्यूट किया तो I इक्वल टू I नॉट, नीचे लिखो all current flows through the inductor, all current flows through the inductor and ब्रैकेट में शॉर्ट सर्किट बोल लिखो, ब्रैकेट में शॉर्ट सर्किट. एक क्वेश्चन करो, समझ में आएगा. So this is a switch, this is a battery, resistance R1 they given as 30 ohms and E voltage they given as 120 volts and resistance and inductor is given. So they'll combine resistance and inductor. R2 is 60 ohms and inductor is 0.2 Henry. Okay. He is telling find the current in R1 and R2. Current find karo in R1 branch and R2 branch. First condition में at just switch is closed, मतलब at t equal 0 में. Second condition में t equal infinity में. Steady state बोलते हैं, t equal infinity को we call as steady state. Steady state. Find karo, use the thing. Tell me, Sriram, when you on the switch at t equal 0, the inductor will act like what? Inductor
Open
will act
circuit.
like? हाँ?
Open
उसमें पढ़ो वो
circuit.
क्या दिया?
Sir, I is equals to 0 now, sir. T is equals to
in
0.
that branch में it will act like a open circuit. So current is 0, I2 is 0. मतलब indirectly only one voltage, one resistance is there. Find करो I1. समझ आ रहा है? I1, I2. Find करो. Because inductor does not allow change in current. So t equal 0 में उसमें करंट नहीं जाएगा, उस ब्रांच में जो भी है वो करंट नहीं जाएगा. मतलब इन द फर्स्ट कंडीशन में I2 तो 0 आएगा, मतलब ओपन सर्किट कर देने का. मतलब यू हैव ओनली वन रेजिस्टेंस, वन वोल्टेज. सो I1 इज E by R, E by R1. So 120 by 30. So it is 4 ampere is the answer for first one. Now t equal infinity में करो.
2 amperes.
I1 I2 कितना है? I1 I2 दोनों चाहिए. At t equal infinity में the inductor will act like a short circuit. It will allow all the current, right? That means in the circuit में you have two resistance connected in parallel and one voltage. So combination of resistance करने का.
Six amperes in each.
6 amperes नीचे भाई, दोनों same resistance हाँ. Why the same current will flow?
Oh,
देखो voltage is same both, right? Use करो E by R1, E by R2 directly आ जाएगा. So I1 is 120 by 30, 4 amperes, and I2 is 120 by 60, 2 amperes. तो I1 I2 separately आपको आ जाएगा. So आपको t equal to 0 में it will act like a open circuit, उस branch में no current. t equal to infinity में it will act like a short circuit, simply short circuit कर देने का. Okay, क्वेश्चन डायग्राम देने से आपको लगेगा ये कॉन्सेप्ट समझ में नहीं आया तो we will think current electricity. When we started doing in the JEE Mains में क्वेश्चन, अरे इंडक्टर को क्या करेंगे, इंडक्टर को नहीं आता है बोल के छोड़ देगा. That's the problem. So दोनों कॉम्बिनेशन में देगा. Okay, चलो. Now growth of current we done, right? Same with decay of current also. Formula almost same but थोड़ा one नहीं रहेगा. That's it. Decay of current. So मान लो this is inductor, this is resistor, there is a switch and one more switch and battery. E. S1, S2. Inductor, resistor. Now initially मान लो S2 is open, S1 is closed. तो करंट स्टार्ट फ्लोइंग स्टडी स्टेट रीच होने के बाद मैं क्या करूंगा, S1 को ओपन कर दूंगा. S1 को ओपन कर दूंगा एंड S2 को क्लोज करूंगा. ओके, फाइनली मैं क्या करूंगा, S1 को ओपन करूंगा, मतलब बैटरी से नो करंट इज फ्लोइंग नाउ टू द सर्किट. नाउ S2 इज क्लोज्ड. नाउ क्या होगा, करंट धीरे 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 इट विल स्टार्ट रिड्यूसिंग करंट. ओके, नाउ कैसे रिड्यूस होगा, एक ही बार रिड्यूस हो जाएगा. वेदर एक ही बार रिड्यूस होगा, नो, बिकॉज इंडक्टर इज देयर. इंडक्टर ऑलवेज हेल्प चेंजिंग करंट को. नहीं 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 नहीं, धीरे धीरे जाएंगे बोल के धीरे धीरे कम करेगा. ओके, नाउ करंट इज हाउ मच मीन्स सिंपली I इज इक्वल टू आई नॉट इंटू ई पावर, वन माइनस नहीं रहेगा, minus t by tau. This is expression for decay of current. I put already in formula sheet. I is equal to I naught into e power minus t by tau is a formula for decay of current when the current is decreasing. ऐसा decrease होगा, exponential decrease होगा. Okay, not suddenly. Now tell me इसका tau के बारे में learn करेंगे. Tau is nothing but L by R only, right? Inductive time constant. At t equal tau find करो. At t equal tau, I is equal to how much? I is equal to I naught e power minus tau by tau is 1. So it is I is equal to I naught into 1 by E, right? 1 by E I told you 0.37. 0.37 times of I naught. मतलब indirectly नीचे लिखो, tau is the time. Tau is the time in which current decays 37% of its peak value. Current decays 37% of its peak value. मतलब उस टाइम में द करंट कितना डिक्रीज हुआ, कितना है उस टाइम में, 37% ओनली डिक्रीज मतलब है उसमें करंट में, सर्किट में दैट टाइम. सो इफ आई ड्रॉ द ग्राफ, करंट वर्सेस टाइम, एक्सपोनेंशियल ई पावर माइनस, राइट, एक्सपोनेंशियल ऑलवेज डिक्रीजिंग ऑर्डर में रहेगा. दिस एक्सपोनेंशियल डिक्रीजिंग. ओके, एंड दिस वैल्यू इज नथिंग बट आई नॉट पीक वैल्यू, एंड धीरे धीरे कम होता जाएगा. एट टाइम टी इक्वल टाउ में, एट टाइम टी इक्वल टाउ में द करंट वाज कितना था, 0.37 times of I naught. So current कितना परसेंट डिक्रीज, 37% डिक्रीज हुआ उस टाइम में, राइट. दिस इज अ डीके ऑफ करंट. अंडरस्टूड. एंड वी लेफ्ट विथ वन स्मॉल फॉर्मूला. ये फॉर्मूला आ गया ना अभी, टेल मी, पूछो आपको. श्याम समझ में आया आपको इंडक्टर का, टी इक्वल 0 में, टी इक्वल इन्फिनिटी में क्या होगा बोल के. ओके, एक छोटा सा एनर्जी स्टोर का फॉर्मूला लर्न करेंगे. एनर्जी स्टोर्ड इन इंडक्टर, फॉर्मूला लिखो. एनर्जी स्टोर्ड इन इंडक्टर में, इंडक्टर में एनर्जी स्टोर्ड एज हाफ एल आई स्क्वायर. दिस इज फॉर्मूला, डेरिवेशन जरूरत नहीं है. इंडक्टर में कितना एनर्जी स्टोर करेगा, इन द फॉर्म ऑफ मैग्नेटिक एनर्जी में स्टोर करेगा, राइट, एल आई स्क्वायर. कैपेसिटर में इट स्टोर्स इन द फॉर्म ऑफ इलेक्ट्रिकल एनर्जी. इंडक्टर में इट स्टोर्स इन द फॉर्म ऑफ मैग्नेटिक एनर्जी, हाफ एल आई स्क्वायर. How they will ask combine with this and the LR circuit में, we'll see. Okay, एक करो. एक voltage is there, inductor is there, resistance is there, switch also is there. The switch is closed at t equal 0. तो close कर दिया. The amount of energy stored in the inductor at t equal 2 seconds में, 2 seconds में कितना energy store करेगा, he telling at t equal 2 seconds में. इनिशियल क्लोज करने के बाद ही वेटेड फॉर 2 seconds, मतलब सम करंट इज फ्लोइंग, राइट. एनर्जी स्टोर्ड इन इंडक्टर. सो वी नो एनर्जी स्टोर्ड इन इंडक्टर का फॉर्मूला क्या है, हाफ एल आई स्क्वायर. एल तो मालूम है 4 मिली हेनरी, बट आई नहीं मालूम. आई कैसे फाइंड करेगा, इन बिटवीन टाइम में एक ग्रोथ हो रहा है और डिके हो रहा है. व्हेन यू ऑन द स्विच, बैटरी इज देयर, व्हेन यू ऑन द स्विच इट इज इंक्रीजिंग करंट, धीरे धीरे इंक्रीज हो रहा है. इंक्रीजिंग का करंट का एक्सप्रेशन क्या होगा, I इज इक्वल टू आई नॉट इंटू 1 माइनस ई पावर माइनस टी बाई टाउ, वे टाउ इज एल बाई आर. इंडक्टर का रेसिस्टेंस ओनली यू हैव टू टेक. ओके, नो करो सब्स्टिट्यूट. एंड आई नॉट इज द पीक करंट, राइट. आई नॉट कितना होगा, आई नॉट इज नथिंग बट ई बाई आर. And he told E value to take as 3. Resistance is also 2 milliohms, right? So I naught is 2 by 2 into 10 power minus 3. So it is current कितना होगा 10 cube amperes. Okay. And tau is L by R. So 4 by 2 milli cancel हो जाएगा 2. Subs करो. So I is equal to I naught is 10 cube into 1 minus e power minus 2 by time कितना 2 seconds, right? 2 by 2. 2 by 2 is minus 1.
So 8000 by 9.
Yes, correct. 10 cube into 1 minus 1 by e. E value 3 ले लो. So I is equal to 10 cube into 1 minus 1 by 3. So it is 2 by 3. 1 minus 1 by 3. 2 by 3. Okay, now substitute here. U is equal to half into L is 4 into 10 power of minus 3 into I square. So 2 by 3 into 10 cube into 2 by 3 into 10 cube. So if you solve, how much you'll get? That is 8 by 9 into 10 cube. Okay. I got 10 power minus 3, 10 power minus 3 cancel. And 2 to cancel. So 4 to ja 8, 3 to ja 9. 8 by 9 into 10 cube. So this much energy stored in an inductor. Okay. So by this, your chapter successfully done. Alternating induction pura.